Hi, welcome to Algorithm Analysis. Today we are going to address the chapter 1, that is Introduction. So in this chapter, concepts, two parts are equally balanced, that are theory and practical. The introduction part consists basics of algorithm. Now let me see layout of today's chapter. First one, what is an algorithm? Second one, characteristics of an algorithm. Third one, data flow of an algorithm. Fourth one, importance of an algorithm. Fifth one, issues of an algorithm. Sixth one, designing factors of an algorithm. Seventh one, types of an algorithm. Eighth one, analysis of an algorithm. Ninth one, complexity of. The next topic is, what is an algorithm? Here, see, three kinds of definition for an algorithm presents here, but all are provides the similar purposes. That means an algorithm is a process required to perform calculations. It's a dimension of algorithm definition. And another dimension, an algorithm is a set of instructions to be executed for desired output. And finally, third dimension of an algorithm definition, an algorithm is a set of rules required for problem solving operation, especially by a computer, but all are provides the similar purposes. The next topic is characteristics of an algorithm. Here we are going to see the primary of or important characteristics of an algorithm. First one, input. An algorithm should have 0 or more well-defined input values. Second one, output. An algorithm should have 1 or more well-defined desired output. Third one, unambiguity. An algorithm should be clear and simple. Fourth one, finiteness. An algorithm should contain a limited number of instructions. Fifth one, effectiveness. An algorithm should be always in effective mode. Sixth one, language independent. An algorithm should be programming language independent. Seventh one, feasibility. Should be feasible with the available solution. Next topic is data flow of an algorithm. The data flow consists the way of algorithm working strategies in a sequential order. The order will consist, first one, problem. So problem behind the process. A algorithm can be a real world problem or any instance from the real world problem. 2. Algorithm. An algorithm will be designed for a particular problem with step-by-step procedures, as we already see. Third one, input. The required or desired inputs are provided to an algorithm always. Fourth one, processing unit. Process the given input and produce the desired output to the user. And finally, fifth one, output. Result or outcome of the program we will display or visualization for the users. Next topic is importance of an algorithm. So there is two kinds of importance we are going to put for the algorithm. First one, theoretical importance. The real world problem is divided into many modules based on theoretical facts. Second one, practical importance. Complete the solution of the problem through the practical implementation. Here note the important thing, every problem is solved with the combination of both theory and practical. So these are the things equally balanced as we see earlier. Next topic is issues in designing of an algorithm. So first one, how to design algorithm. So we follow some rules to design an algorithm to avoid this design issues. Second one, how to analyze algorithm. We compute some factors to evaluate the efficiency of an algorithm. So it is properly selected to solve these kind of issues. Next topic is designing factors of an algorithm. First one, modularity. Second one, correctness. Third one, maintainability. Fourth one, functionality. Fifth one, robustness. Sixth one, user friendly. Seventh one, simplicity. Eighth one, extensibility. Greedy algorithm. Fourth one, dynamic programming. Fifth one, branch and bound algorithm. Sixth one, randomized algorithm. Seventh one, backtracking. So the next topic is analysis of an algorithm. Here the algorithm, in two ways it is going to be analysis. So first way, priori analysis. The second way, posterior analysis. Priori analysis means, priori analysis is the theoretical analysis of an algorithm which is done before implementing the algorithm. So it is done before implementing the algorithm. Various factors can be considered before implementing the algorithm, like processor speed. We are going to consider the factor as processor speed. So next one, posterior algorithm means, posterior analysis is a practical analysis of an algorithm. The practical analysis is achieved by implementing the algorithm using any programming language. This analysis basically evaluates that how much running time and space taken by the algorithm we are going to consider for this. Next topic is complexity of an algorithm. The performance of the algorithm can be measured in two factors. First thing, time complexity, and second thing, space complexity. The time complexity means the time complexity of an algorithm is the amount of time required to complete the execution. The time complexity of an algorithm is denoted by the big O notation. The another thing is asymptotic notation. The second one, space complexity. An algorithm space complexity is the amount of space required to solve a problem and produce an output. Similar to the runtime complexity, space complexity is also expressed in big O notation.